Hi viewers, I am AfreenAli. I brought this video for fire sprinkler hydraulic calculations and design density. Kindly subscribe my channel. Question: how to calculate fire sprinkler hydraulic calculations and design density? Answer: in fire sprinkler design, one of the most important concepts is the principle of water density, yet many fire sprinkler system design engineers do not fully understand the concept. This short instruction will hopefully fulfill this requirement. We often refer to design density and lazy preference to design density of discharge, which, in turn, is a short way of saying density of application of water. This is an unusual use of the word density, since we know, of course, that the density of water is 1. The density of application, however, means how much water we apply over a certain area, much the same as pressure is a force applied over a unit area. We are, therefore, talking about a volume of water, spread over a certain area in a unit of time. Volume can be measured in liter. Area can be measured in m2. Time can be measured in minutes. The density of water application would be measured thus: volume, area x time a liter per cubic meter by min. It is necessary to bring this formula to a manageable state by changing the units. As a liter of water is defined as cubic decimeter, which is 10 centimeters times 10 centimeters times 10 centimeters, 1 L 1 cubic decimeter 1000 cc. Hence 1 L 0.001 cubic meters 1000 cc and 1 cubic meter, i.e. a cubic meter, which is the SI unit for volume, is exactly 1000 L. Therefore, we can rewrite the formula dmx dmx dm 10 decimeters by 10 decimeters. This can be simplified by cancelling out dm. 100 minutes equals 100 millimeters, 100 minutes equals 1 millimeter, 1 minute equals. The density of application can, therefore, be measured in millimeters per minute, millimeter per minute. Whichever route you take, it is important to realize that when we use this strange, apparently linear unit, we are talking about a volume of water discharged over an area of 1 square meter in 1 minute. In the case of ordinary hazard installations, N12845 with a density of discharge of 5.0 mm per minute, bearing in mind that this really means 5 L per minute 2 per minute, then we are applying less than half a bucket full of water on every square meter each minute. The art, of course, is how you tell it, or, in this case, how you apply it. The sprinkler head distributes the water in an even pattern so that in the case of OH3, each of the 12 square meters covered by the head receives its share of water. When testing a sprinkler head, the floor is covered with 1 square meter trays, and after a discharge for 1 minute, there should be water in each tray to a depth of 5 millimeters. The volume of water in the tray would be 5 mm by 1000 mm by 1000 mm equals 5 million cubic millimeters. Since there are 100 by 100 by 100, i.e. 1 million cubic millimeters in 1 cubic decimeter, the volume of water will, of course, be 5 cubic decimeters or 5 liters. Taking OH3 as an example, if we design for a maximum of 18 sprinkler heads operating each capable of covering 12 square meters, then the maximum area of operation will be 18 by 12, m2 equals 216 square meters. If each of the 18 sprinkler heads is discharging 5 cubic decimeters per square meter every minute, then we will require a flow of 5 by 18 by 12 cubic decimeter per minute equals 1080 cubic decimeters per minute. In calculating pipe sizes, this is approximated to 1000 cubic decimeters per minute. Now we know the theory of design density, we can use it in a fire sprinkler hydraulic calculations to find the quantity of water required to flow from a fire sprinkler. If we know the area a sprinkler head is covering and the required design density, then we can use the following formula. Area x density equals quantity. Therefore, if we have a fire sprinkler head which is covering 8 square meters and we require 12.5 millimeters per minute, 8 square meters times 12.5 millimeters per minute equals 100. This would be the minimum flow rate required for the sprinkler head to prove the correct design density. The specific design density to be used for design purposes is determined by reference to the occupancy fire hazard of the building. Once this is known, the applicable design standards such as N 12845, BS 9251 or NFPA 13 will have tables of occupancies from which you can find the required design density.